Hi folks, we're going to talk about highlights from week 4, specifically hierarchical regression analysis. So what we're going to talk about here are how to formulate research questions for hierarchical linear regression. We're also going to talk about how to approach the analysis, and that's going to be very similar to what we did last week with multiple regression. And we're also going to talk about interpreting results, and some of that's going to be just a little bit different and some is going to be very similar to what we did last week with multiple regression. So let's talk about some different ways that we can formulate research questions for hierarchical linear regression. So here's an example question that's adapted from the text, page 207, and we saw this analysis in our course binders. So we might word the research question as follows. Do racial attitudes, ethnic identity, and collectivism predict therapist awareness of cultural barriers over and above years of experience and attendance at specialized training? So what we see here is we're adding the variables in groups, or what we call blocks. So we really want to know about these 3 variables: racial attitudes, ethnic identity, and collectivism. Those are added in the last block, block 2. We want to know how well they predict our dependent variable, therapist awareness of cultural barriers. But how much do these independent variables predict over and above years of experience and attendance at specialized trainings, 2 other independent variables? So that's one way we can word a research question for hierarchical linear regression. Another way we can word it is similar to what we talked about last week. We might ask, which variables most strongly predict lower depression, which is our dependent variable, in the presence of all other variables? And here again we have 3 blocks of variables. So do demographic variables, program participation variables, or participant motivation and self-efficacy variables better predict depression when all of those variables are considered together? A third way we could ask a research question for hierarchical linear regression: how much variance in symptoms, which is our dependent variable, is accounted for by depression and anxiety, which is one group of our independent variables, when controlling for family support, another independent variable? Or instead of controlling for, we might say over and above family support. And this is from the video that we have in week 4 that was done by Todd Grande, his hierarchical regression video that we link to on our Canvas website. So here again we have 2 blocks of independent variables. We're thinking about one of those blocks as being a control variable or a group of control variables, so we enter that first, and then what we're most interested in is the second block of variables, depression and anxiety. So we can use the phrasing controlling for whatever our control variables are, or over and above whatever our control variables are. So the way that we approach research questions for hierarchical linear regression, the key thing is that you, the researcher, are determining which variables to enter and in what order. And this is very much the preferred method by most statisticians and by most people who are writing statistics textbooks. Another thing is that variables are entered in blocks, and there might be 1 or more variables within each of those blocks. The SPSS output calls these blocks of variables models, and it numbers them. The variables entered in earlier blocks are considered covariates for variables entered in later blocks, and that's talked about in Myers et al. In our textbook. The selection of variables and the blocks of variables should be based on theory, either established theory or empirical research, or it can be based on your assessment of the existing literature. This is also called sequential analysis. So hierarchical linear regression is also called sequential analysis. But the key differentiation between standard multiple regression And hierarchical linear regression is that you, the researcher, are determining which variables to enter and in what order, and there's more than one group or block of variables. Very often you're doing this to test theory. Okay, in terms of how to approach the analysis, a lot of these steps are exactly the same as multiple regression. So I'm not going to go through this again. I talked about this in our week 3 highlights video, so you can see that video, but it's all the same in terms of data cleaning and data screening. It's also the same in terms of the methodological assumptions. So again, you can see that week 3 video. It's also the same in terms of the statistical assumptions. So it's not that the main difference really is how we conceptualize the variables and how they go into the analysis. However, there is a slight difference in how we interpret the analysis. We do that just a little bit differently. So the same step is, this first step is the same. Is each block or each model significant? We check the ANOVA table. But the next step is a little bit different. What is the R-squared change for each block or model, each group of variables that we entered? By how much does R-squared increase with each block? We see that with the R-squared change. That's the main difference when we look at it, when we analyze the results from a hierarchical linear regression. We still want to know the overall variance, and this is in the final block. We check adjusted R-squared. Another slight difference in hierarchical linear regression is how do the coefficients for individual variables change in each of those blocks in the presence of all the other variables. So we want to see how the standardized betas change in each block. And, for example, does it go from significant to non-significant or vice versa? Or how much does the magnitude of that standardized beta change? Does it get larger or smaller? For the final model, we will still want to look at the squared semi-partial correlations of our significant variables, and we still want to compute the structure coefficients in the final model for our significant variables, and we'll note which block they're in. So this has a couple of differences, mostly in looking at the R-squared change for each block and in seeing how standardized betas change. Otherwise, the interpretation is very similar to multiple linear regression. The effect size calculation is also exactly the same, and we would still do this on the final model in our hierarchical linear regression. So for your learning 2 or 3 times this semester, I hope that you'll reread just the first half of chapter 6A and 6B of our Myers et al. Text that talks about hierarchical linear regression. Also check the annotated output in week 4 of the course binder. We have a video on hierarchical linear regression and also on our standard multiple regression, but watch those videos again periodically throughout the semester. And also you might be doing a hierarchical linear regression for your data analysis assignment, so those handouts will help you do that. So just remember, you can do this. It's iterative, it's reviewing the materials again and again, and thank you so much for your attention.